In this section, we'll be working with percent problems. We'll actually be converting certain quantities into percents. We'll start out by looking at a few decimals to percent conversions, which are actually fairly simple, and then we'll look at a few problems where we're converting fractions to percents, which we actually already know how to do, but they take an extra step or two, but fairly simple. Okay, so let's take a look at a few decimals. We want to convert the following decimal into a percent. We have 0.22. Okay, not a whole lot to do this and converting a decimal to a percent. This is simply what we want to do. When we're talking about a percent problem, we actually looked at one, I believe, in the advanced ratios section. A percent problem means part of 100. So when we're talking about converting a decimal into a percent, we want to move the decimal, the equivalent of 100, the value of 100. We know that when we're working with decimals that, what's the 100th place? Well, it's the second place. So let's move the decimal 2 spots to the right. So 0.22 is going to become 22. So when we're converting a decimal to a percent, what we do is we move the decimal 2 places to the right, so it's actually right here, and we tack on a percent sign. Okay, now this kind of looks funny. We actually can omit the decimal. Anytime we have nothing but zeros to the right, which actually there's just an unlimited amount of zeros, we can omit the zeros and the decimal. So we can actually just write this as 22%. So converting a decimal to a percent, let's take the decimal 2 places to the right and just tack on a percent sign. Let's look at a few more of these. Let's get some more practice. Let's take 0.02 and let's convert it to a percent. Now here we have the 0 in between our decimal point and our 2. Zero placements, which these are actually called placeholders, are very important. We want to learn when to use these and when not to use these. Anytime there's zeros, nothing but zeros after the decimal point, we can omit them. But if they're to the left of the decimal point, we actually use 1. And if they're between a decimal point and a number, we have to put them there. Okay, and actually this is very evident when we look at this example, because to make this into a percent, we move it 2 places to the right. We move the decimal point 2 places to the right. And this becomes 2 and tack on our percent sign. So 0.02 is the same as 2%. Let's look at another one. Let's say we have 0.002. What do? Well, what we do is we take the decimal and move it 2 places to the right. So this becomes, now we have a decimal and to the left of 2, so it's going to be a point, which means we need a 0 right here. We put 1 0 in front of our decimal point. Okay, and then we can omit everything to the right of it after the last number. And then don't forget our percent sign. So 0.002 is the same as 0.2%. Okay, let's keep going. Let's say we have 0.87. Okay, we don't have any zeros over here, but it works the same. We move our decimal 2 places to the right, which gives us an 87%. Okay, fairly simple. Let's do a couple more. Let's say we have 1.34. Okay, here we have a 1 on the left side of the decimal, but we're going to approach it the same way. We're going to move the decimal 2 places to the right, and this is going to give us 134. Don't forget our percent. Don't get excited when you see a percentage that actually exceeds 100. This happens actually quite often in what are called percent of change problems, which we'll actually be covering in a later video. So this is nothing to write home about. 134% is perfectly fine. Let's take a look at one more. Let's say we want to convert 9 into a percent. Well, when we have a whole number, 9 is actually the same as 9.0. We have a decimal point, but we omit it just like we did up here because there's nothing but zeros to the right of the decimal point. So what do? Well, we simply move it 2 places to the right. We can just fill in a 0 to the right since there's an unlimited amount of them, and we can use as many as we need. This is 900%. With whole numbers, it helps to write out our placeholders to ensure that we don't make any mistakes. So be sure we get zeros down as the idea of placeholders, because that's very important. Let's move on. Let's transfer some fractions to percents. Let's express the following fraction as a percent. Let's say we have 2 over 5. Okay, and we want to convert this fraction to a percent. When we do so, we'll use what's called a proportion. If you need a refresher, you can go back and review the proportion videos for some quick practice. And this actually makes sense because a percent is actually a number over 100. So, which actually we want to be equal to our given fraction. So let's take a look. So to convert 2 over 5 to a percent, we're going to want to know what number over 100, because percent means a part of 100, what number over 100 is equivalent to the ratio 2 over 5. So we have a proportion problem, and we know how to solve these. We simply cross multiply. Multiply 2 times 100 equals 5 times x. So let's do this. 2 times 100 is 200 equals 5 times x is 5x. We can solve this by dividing both sides by 5. This will isolate our variable x. And 200 divided by 5 is 40. So x goes here. So we have the ratio 40 over 100. And whenever we have our fraction over 100, we can easily spot the percent because it's just this numerator right here. So the answer here is 40%. Excuse me, 40%. So basically, when we have a fraction, we want to use what we know about proportions to convert the fraction into a ratio or another fraction where we have a denominator of 100. Okay, that's the whole objective here when converting fractions to percents. Once we have that denominator of 100, the percent is actually just the numerator. So we just write it with a percent sign. Fairly simple. Let's just use what we know. Let's say we want to convert 7 over 11 into a percent. Well, we want to use what we know about proportions to find what number x over 100. We want to know what this ratio, what x is, to make this ratio equal to this ratio. So we simply cross multiply right here, which will give us 7 times 100 is 700 equals 11 times x is 11x. Let's divide both sides by 11. These two will cancel, which will give us x equals 700 over 11. Okay, now this doesn't divide evenly, but using our calculators, which I usually don't like doing too often, but sometimes you're forced to, this equals 63.64. And this is rounded to 2 decimal places, which is pretty standard, and our answer is 63.64%. So 7 over 11 is the same thing as 63.64 over 100. Okay, and this is simply our answer right here. Just put a percent sign on it. All right, let's do a few more. Let's say we have 8 over 3. We want to know what percent is the equivalent of the fraction 8 over 3. So how do we do this? Well, let's set up our proportion. We want to know what number x over 100 makes this ratio equal to this ratio. Okay, so let's go ahead and cross multiply here and here. And we have 8 times 100 is 800 equals 3 times x is 3x. Let's go ahead and divide both sides by 3 to solve for x. We get x equals 800 over 3. And once again, going to our calculator, this will equal 266.67 rounded to the nearest 2 decimal places. And 266.67% is our answer for 8 over 3. Okay, if we want to write it in fraction form, one more time, 266.67 over 100 is what we get here. Okay, and this will be our answer with a percent sign on it. All right, let's do a couple more. I think we're getting the hang of this. Let's take a look at 9 over 34. We want to convert 9/34 into a percent. Let's go ahead and set up our proportion. 9 over 34 equals x over 100. Let's go ahead and cross multiply here. 9 times 100 is 900. 34 times x is 34x. Let's go ahead and divide both sides by 34 to get x by itself. And going up, x equals, well, we can go ahead and simplify 900 over 34. Simplify it into 450 over 17. They're both even, so we can take out a 2 out of the top and the bottom. And this will give us 26.47. So 26.47 over 100 is the same thing as 26.47%. And that's the same, that percent is the same as 9 over 34. It's just in percent form. All right, let's squeeze in a couple more. We're running out of time here. Let's take a look at 5 over 6. We want to know what is the fraction 5 over 6 in percent form. Let's set up our proportion. 5 over 6 equals x over 100. And let's go ahead and cross multiply here. 5 times 100 is 500. And 6 times x is 6x. We can isolate our variable by dividing by 6, doing the same thing on both sides. X equals 500 over 6. They're both even, so we can factor out a 2 out of the top and bottom, which gives us 250 over 3. We still got to run to our calculator for this, but I want to get in the habit of simplifying every time when we can. And this is going to equal 83.33%, rounded to 2 decimal places. Okay, we're running out of time and running out of room here, so let's go ahead and get a quick review of what we learned for. We're converting decimals to decimals to percents and fractions to percents. When we're converting decimals to percents, we want to be careful with our decimal placing and our zeros, our uses of zeros, because they're important placeholders. Because what we do to convert to a percent is we move the decimal place 2 places to the right, and then we tack on a percent sign. So let's remember our rules for using zeros as placeholders. And when we're converting fractions to percents, we want to set up a proportion where our fraction is equal to x over 100. We want to convert our fraction into a fraction that has a denominator of 100, and then simply our percent will be just the numerator. So it makes things very simple. It's just, we know how to do it. It just takes it a couple extra steps than when we're using with decimals. So practice this a little bit, and in the next video we'll actually go the opposite direction. We'll be converting percents to decimals and then percents to fractions. So I'll see you soon.